Hi, this is John Roberts from Pivotal Software. This video is covering Pivotal Greenplum Cloud Native features in the Azure cloud. Let's first get started with gpsnap. This is a utility to take and restore backups using Disk Snapshots in Azure. You can see in cron tab that gpsnap runs every 10 minutes. It's checking a configuration file to see how often gpsnap should actually execute. By default, it executes weekly, but you can easily change this to run more or less often. For the demonstration, I'll create a table, and then later I will drop the table and do a restore to recover that table. gpsnap create is all you need to do. It will shut down the database to get the database in a consistent state. It'll then execute the snapshots in parallel for all volumes in the cluster. When the snapshots are in a ready state, the database is then restarted and you can start using the database again. gpsnap restore is the next demonstration. We'll go into the database and drop that foo table. Now I will do a gpsnap list to show the snapshots and do a restore. This will restore the entire database, including my table foo. This portion of the video has been sped up for demonstration purposes. The first thing it does is stop the database. Next, it unmounts all volumes in the cluster. It detaches these old volumes. Then after that, it will delete the volumes. After the old volumes have been deleted, new volumes will be created using the snapshots. Once the volumes are ready, they will be attached to every virtual machine. All this is done in parallel as well. After the volumes are attached, they will be mounted. And then the database is started again. And you can see my foo table has been restored, as well as all of the other database objects. Self-healing. Self-healing is an automated recovery of Greenplum services when an Azure VM is replaced due to an Azure failure. So using gpstate, we can see that the database is in a normal state. And for my demonstration, I'll create a table again so that I can show that we can still use the database while the database is in a degraded state. This is thanks to database mirroring that's built into Greenplum software. To simulate a failure, we will shut down one of the virtual machines. When Azure detects a virtual machine is bad, it will stop that virtual machine and create a new virtual machine and attach the disks associated with that virtual machine, and then start the new VM. So this is a good simulation of what happens when a VM dies because of something failing in Azure. You can see that gpstate will show that there are 4 segments that are actually failed now. I can still use the database using pSQL. I can still access my table. So let's start this virtual machine again and to see how the self-healing would completely put everything back to normal. Pinging that host, I can now see that the virtual machine is now up and available. Run gpstate. I will see that 2 mirror segments are still acting as primaries. Run gpstate again, and the recovery has completed.